In the previous video, we looked at two special triangles called the isosceles and the equilateral triangle. In this one, we're going to look at another special triangle which is called a right triangle. Recall, right triangle is a triangle where one of the angles is 90 degrees, which is denoted by this box. Now there are some terminologies. Now one way of labeling a triangle is that we use capital letters for the points and small letters for the side length. So for example here, A equals the side BC, small b equals the side AC, and small c equals the side AB. And the way you label them is they are opposite, right? So small b is opposite B, small a is opposite A, so on. Now this is very important because all throughout this course we will be working a lot with right triangles and you need to know this naming system. Furthermore, these two are known as the legs of the triangle. It's sort of the triangle stands on them. And this side is called hypotenuse. There is a result called the Pythagoras Theorem, which says the sum of squares of the leg equals the square of the hypotenuse. The sum of squares of the leg, that's a squared plus b squared, these are the legs, equals the length of the hypotenuse, which is c squared. Now again, be aware that I could change the labeling of this triangle, right? Now this would be A, and this would be B, and this would be C, and in this case, B squared plus C squared equals A squared. So instead of thinking as A squared plus B squared equals C squared as Pythagoras theorem, it's safer to think of it as sum of square of leg equals the square of hypotenuse. That is, so long as you also know what the legs of the triangle mean and what the hypotenuse means. It's an example problem. There are rafters which are 18 feet long and they are on an equally pitched roof and they have a span of 24 feet. We have to determine the rise of the roof, which in this diagram is FG. So let's convert this into a diagram here. So what I have here is this is F and this is D and this is E. Now I'm just considering the triangle. Now if the overhang is 2 feet, then FD should be 16 feet and 16 feet for FE. That's because you're given that there's an equal overhang on both sides. So if the whole thing is 18 and this is 2, the remaining is 16. Now that immediately tells me that this is an isosceles triangle. Now the height is always measured perpendicular. Recall the words altitude, height mean 90 degrees, which means that these sides have to be equal. So DG equals GE, which further equals half of 24, which is 12 feet. Why? Because altitude of isosceles triangle bisects the base. We're still not done. We need to find FG. Then we have Pythagoras theorem, which says that df squared equals dg squared plus fg squared. And this is by Pythagoras theorem. And df is given to me is 16. dg we just found is 12. And fg is what I'm interested in finding. Plugging that into the calculator, I get 256 minus 144. I get fg squared is 112. So the height of the roof is going to be square root of 112, which you can plug into the calculator and you get a value which is a decimal number. There are some more examples. Let's say you're given this irregular shaped plot and you have to find x and y to the nearest meter. You can pause and attempt this problem on your own and then verify your answer. The first things to observe here is there are a bunch of right angle triangles that you have, right? Which is gonna, so one observation is that you have this right angle triangle right here on this top. This is 124 meters, this is 60 meters, and this is the hypotenuse. Let's say I call this A. Then I know A squared is 60 squared plus 124 squared. And I can find the value for A, which gives me this length. Now what? How can I use that to find X and Y? Now first observation here is if you look, then X is nothing but A plus 50, right? Because X is this entire horizontal length, and you're given this part is 50, so 50 plus A would give you X. Alright, now what we have here, if I complete this figure, I can make another right triangle here. If I look at this right triangle, this is X, this is Y, and what is this? Again, if this whole thing is 90, this whole thing is 90, then what's left here is 90 minus 50, which is 40. And I have X. I can find Y squared as X squared plus 40 squared, and thus I can find Y. Okay, so that's I've outlined the process for finding it. I'll ask you to complete this on your own, and then you can verify the answers, which will appear as a different problem on Google Classroom. Second one says, you have a rectangular metal sheet. It's 46 inches by 96 inches. And you question is, can you cut a right angle triangle of height 46? So that's 46 and hypotenuse 110. That's only possible if this length is at least 110 inches. Now if I call this X, this is a right angle triangle, I get that X squared is 46 squared plus 96 squared, and I solve for X. And then you will be able to answer this question. If you look at this value, is it at least 110 inches? Because if it is not, that means you cannot cut a right angle triangle which has the height 46, right? Because that's going to require more amount of sheet. If it is less, then you can. Okay, that's the end of this video.